Welcome to qnawire.
In this question, we're told that we have two spheres that are arranged as in figure 9-20, and we're to assume that sphere 1 has a mass m1 of 50 grams and initial height h1 of 9.0 centimeters, and that sphere 2 has a mass of 85 grams, m2. After sphere 1 is released and collides elastically with sphere 2, for part A, what height is reached by sphere 1, and part B, what height is reached by sphere 2? And then after the next elastic collision, what height is reached by C sphere 1 and by D sphere 2? Hint, do not round off values. Okay, so for part A here, we're going to refer to the discussion in the textbook, the sample problem that's called elastic collisions, two pendulums, which uses the same notation that we use here. And for some important details in the reasoning, we choose the right word in figure 9-20 as our positive x direction. And we use the notation v where we refer to the velocities, okay? Since the algebra is fairly involved, we're going to find it convenient to introduce the notation delta m equals m2 minus m1, just to make things a little simpler, okay? So we'll write that up over here just so we know. Delta m, the change in m is just m2 minus m1. That's going to pop up a lot, and so it's just going to save us some time in our writing here. Okay, so v1 initial then is going to be equal to the square root of 2 times gravity times h1, okay? And then v1 final, so this is part A, v1 final is equal to m1 minus m2, and m1 minus m2 divided by m1 plus m2 okay, multiplied by v1 initial, which equals minus delta m over m1 plus m2 times the square root of 2 times g times h1. But since we have conservation of energy, which says that m1 times g times h1 final is equal to 1/2 m1 times v1 final squared right? So if we use that, we can solve for h1 final, right? Since the m1s are going to cancel here. And h1 final is going to be equal to delta m. So we're just solving for h1 final in this equation here. So h1 final then would be 1/2 v1 final squared over g, but we're going to plug in v1 final up above for the v1 final squared in here. So we're going to have delta m over m1 plus m2 squared. And of course, when you squared the root 2gh1, that just becomes 2gh1, and the g's are going to cancel and the 2's are going to cancel, so you're just left with this being multiplied by h1. So you plug in all those values for m1 and h1. Remember, delta m is m2 minus m1. And this comes out to be 0.60. And the units here are centimeters. And we can box that in as our solution for part A. Now, for part B, we're asked to do the same thing except for doing it for sphere 2. Okay, so now we have V2 final is equal to 2m1 divided by m1 plus m2. And then this ratio here is multiplied by v1 initial, which is the square root of 2g h1. Now, as before, we're going to use conservation of energy. So we're going to have M2 times G times H2 final is equal to 1/2 M2 times V2 final squared. Okay, well, once again, the masses cancel, and we're going to solve for H2 final. Which is going to give us H2 final then is 1/2 V2 final squared over G. So we plug in the value for V2 final squared. And this comes out to be 2M1 over M2 plus M1. And this is all squared. And then when you square root 2GH1, the 2 and the G cancel, and all you're left with is H1. So you plug this value into the equation, and this comes out to be 4.9 centimeters. We can box that in as our solution to part B. Okay, now for part C, it asks us to find the height that is reached after the next elastic collision by sphere 1. And then for part D, we're going to do the same thing for sphere 2. So we're going to call this one V1 double F, since this is the next final. And this is going to be equal to delta M over M1 plus M2 multiplied by 2GH1, which is just V1, plus 2 times M2 divided by M1 plus M2 multiplied by negative square root 2 times G. And this is H1 final, by the way, since this is next final, so I forgot to write that here, times H2 final, which is the second value that we found for part B. Okay, so we can kind of rearrange and simplify this a little bit. This is negative delta M divided by M1 plus M2 and this is multiplied by delta M divided by M1 plus M2 times the square root of 2GH1 minus 2M2 divided by M1 plus M2 multiplied by 2M1 divided by M1 plus M2 times the square root of 2GH1. Okay, and we can simplify this even more. We'll do that on the next page. This is equal to, remember this is V1 final, so the next final is equal to negative delta M squared plus 4 times M1 plus, or excuse me, M1 times M2 divided by M1 plus M2 squared plus M2, all of that squared, multiplied by the square root of 2GH1. Well, if you carry out everything in the, we'll put it in parentheses. If you carry out everything in the parentheses, this comes out to just be equal 1. So this is equal to the square root of 2GH1. So you plug in the value for G, which is 9.8 meters per second, right? Or actually, before we do that, because what we're trying to solve for isn't V, excuse me, it's not V1 final, it's H1, the next final position of sphere 1. So again, we're going to use conservation of energy. So we have M1G H1 final is equal to 1/2 M1 V1 final squared. Okay, and we're going to use the same trick as before. This M1s go away, and then we're left with H1 final is equal to, when you square V1 final squared, you have 2GH1. So the G's are going to cancel, and the 2 is going to cancel with the 1/2, and you're just going to have H1 final is equal to H1, which is equal to 9.0 centimeters. Okay. And then for part D, well, since H1 final is equal to H1 and we have energy conservation, that means H2 final has to be equal to 0. We can box that in as our solution to part D.